The idea behind this performance pattern is to spread out the demand of high-usage objects spatially to different objects or locations. The result of spreading this demand is a reduction in the contention delays for the objects, since this takes away from congestion that could have otherwise been caused. An example usage for this performance pattern is with Google Maps. If the application recognizes that there is a traffic jam caused by a car accident along your route, then Google Maps will update the route using an alternative route to avoid the bottleneck from the original route. In terms of problems, the first problem that can be caused occurs frequently within database systems at times where many processes are requiring exclusive access to the same physical location. This is why the choices on organization of data are so important. A second problem that can occur is when several processes must coordinate with the same singular concurrent process. Traffic jams will get worse and worse under high loading conditions where the single concurrent process cannot keep up the load. The third possible problem is when a single dispatching process has received inbound requests and determines which subsequent process is to handle the requests. If the arrival rate of the inbound request starts to exceed a certain limit, then the result is congestion.
The problems that we looked at are all able to be addressed using an alternative routing performance pattern. We create alternate routes by finding patterns that reduce the overall workload and still have a valid outcome. In the database access problems mentioned earlier, we can try to reference other physical locations in storage. This might be accomplished by creating a hashing algorithm that uses separate buckets or working with multiple databases. In the process coordination problem, requests might be routed to different processes. In the specific case of processes making serialized updates to a RAM databank, there might be a parallel process used to instead update separate parts of the databank. The instances mentioned are also examples of the spread the load principle, since they route access to different physical locations of a hardware component.
There are many benefits to the performance pattern alternate routes method. The main and most crucial benefit is that it improves the responsiveness and scalability of the system. It also minimizes the potential of fluctuations of variability in the system's performance. Moreover, it minimizes the bottlenecks and reduces the delays of serialization in the system. There are also consequences by incorrectly implementing the alternate routes pattern. It is crucial that the alternate routes do in fact spread the load spatially, or else you may experience congestion or bottleneck effects within the alternate routes.
So to sum things up, problems occur frequently in database systems when many processes need exclusive access to the same physical location, usually to execute an update. Alternate routing is needed when several processes must coordinate with a single concurrent process, when a single dispatching process receives inbound requests and determines which subsequent process is to handle the request. For the solution in the database access problem, find alternate routes to reference other physical locations in storage. For the process coordination problems, find alternate routes for sending requests to different processes. For the one inbound dispatch problem, use multiple instances of the dispatcher. The solution should include the spread of the load principle. Benefits of using alternate routing are improved responsiveness, minimize potential fluctuations of variability, minimize bottlenecks, and reduce delays of serialization. The main consequence of using alternate routing is that there is a chance of a bottleneck occurring at the alternate route, kind of like when a bunch of cars use the same alternate route, creating more traffic at the alternate route. In general, it must be made sure that the load is actually spread spatially.